I have a question for you guys. Is everyone comfortable doing finding one's complement?
Uh, Decently. I mean, we should probably go over it since we know that's going to be on the review page.
So let's
Yeah, I
go.
think it's a good idea to go over it, but I'm comfortable with it.
Okay, so we have 32. Find the one's complement of 32. 32 is, see if I remember this, 2, this is 2, 4, 8, 16, this is 32 in binary. So finding the one's complement of this one is just
Flipping them.
right.
Mm-hmm.
Yep.
This is 32, this is the one's complement. Same thing for 64. 64 is this much, and then 1, 64, and then one's complement is a 0. Everyone got that?
Yep.
Yeah.
Right, good. So let's
I'm
move
just writing it.
complement. Finding the two's complement of 32. Let me see how many zeros are there. 1, 2, 3, 4, 5, 6 zeros. 6 places. So 1, 2, 3, 4, 2, 16, 32. Yeah. So choose complement. For the choose complement, we do the exact same thing.
Flip it.
And now you add 1. This whole thing becomes 0, 0, 0, 0, 0, and then a 1. It turned around because 32 on this one, on this size, is the maximum size. But this is the choose complement of 32. And it's the same thing for the 64. The 64 just, we add one number here. So it becomes 0, 0, 0, 0, 0, 0, 1. We add 1. We flip first. Now, after we flip, we add,
Add 1.
and then we retain 1, 0. Oops. We retain 1, 0, 0, 0, 0, 0. So that's the choose complement. Let me get another example here.
So I know somewhere, maybe I just have to find it in my notes, but there was like a specific rule that would only apply to one. I don't know if it was one's complement or two's complement. Yeah, I want to try to find it. Because I wrote it in, I got confused.
So the difference from one's complement and choose complement is the choose complement is only for negative numbers. So this number over here is reserved for negative numbers. So
Oh yeah,
yep.
because
So
if it's
this,
a one or a 0 in front, that determines like what it is,
yes.
right?
Yeah, so this number over here, let me get a red different. This one number here is asking, is it in, this is what it's asking, is it negative? This number here is negative because it has a 1 over here. If this was a 0, this one, like this one over here, this is positive. Make sense?
Yes, perfect.
So let me add another one over here. Let's find the two complement of this number over here. So this number is 10101. Choose complement. What do we do first?
Flip all the
two's
bits
complement.
and then add 1.
So 0, 1, 0, 1, 0, and now we add 1. So this becomes 1, 1, 0, 1, 0. So this is the choose complement of this number over here. So this number over here is not negative. So this means that this number originally was negative and I flipped over. So that's the choose complement. So sometimes if we're talking about one's complement, then this number is not negative. It's positive. Okay.
Yeah, because you're just flipping it.
Good. So let's move on. Let's see. So let's go over this first.
Yeah, this is the one I like need help on or need a refresher on.
All right.
What is FA? What does that mean?
This is
Missing something?
this is an hexadecimal number. Yes.
Yeah, because it turns into like letters.
Yes.
Oh, that is in hex. Okay, there was no base 16 on it. Never mind.
Yeah.
I've done so much binary and conversion for like every single class I've had to deal with. It's ridiculous. If I fuck this up on the test, I'm be pissed.
Yeah, it's a
This
little.
is my first time ever doing it, so I'm like,
Really? Oh, it's so easy. You'll do it in literally every single class.
It's usually
That's always-
decimal, hex, and binary. Sorry.
Yeah,
those
I had to
three.
do octal for CS1 also, so it's
Oh
not
yikes!
totally unfamiliar.
So the guy that asked for help with this, do you know how to write 10 in binary?
like, if you were to tell me that, like, probably not.
All right. So
Unless I
way-
like look, obviously, but
so the way you do it, I'll do it over here, so you can always make that check in your head. So a binary number is always like something like this. So let's say this is a binary number. This number over here is 2 to the 0th. This over here.
Oh yeah, he doesn't.
One. So we remember this, right?
Yes.
So
Every space.
yeah. So
Step
if
up one.
we want to write 10 in binary, this would be something like 8 plus 2, right?
Mm-hmm.
So that's 8 plus 2. Let me see. 1, 2, 4, then 1, 2, 4, and then 8. This is 10 in binary. Makes sense?
Yeah, because you just go from the spaces.
You just go from 2 to 1. 1, 2, 4, 8, 16, 32, 64, 128, and you just go on. But to make any other number like this, the way you do it is like this. You have 10, and then you divide it by 2. How much is this?
10 divided by 2, 5.
5. What's the remainder?
0.
0. 5 divided by 2.
Where are you like asking me?
Yeah, 5
Like
divided by
2.5 or 2
2.5.
remainder 5.
But this is we are dividing integers. This is just integers. So we will have 4 remainder 1.
Oh.
So 4
Okay, yeah.
divided by 2.
And then would it again just be? Yeah.
Whoops, sorry, I'm thinking ahead. It's 2 remainder 0. 2 divided by
Yes.
2. It's 1 remainder.
Will just be 0.
Remainder 0. And then 1 divided by 2 is 1 divided by 2.
Like
0 remainder.
0.1.
And then from here, if I recall correctly, you go from down up.
Yeah, when you're doing
Yeah,
it
you're
this way, you
correct.
invert it.
Oh,
So you go
okay. I
up to
remember
down.
doing this in class.
So
I always found the way he did this really annoying and really backwards, because I just memorized all the the
It's-
powers of 2, because you're gonna see them over and over and
It's
over again.
good to know the
every single
base
time.
and to know this. It just depends on how much time
Yeah.
you're allotted.
Yeah.
Because I'd recommend the base method, but if you have less time, well, actually, I guess it depends. I'm
Depends
used
on
to
what
the
you're more
base.
comfortable with.
Yeah, I'm used to the base method.
I made a mistake. What a mistake did I did? There's something wrong.
10 in binary should be
Should be 1.
Hold on, I'm looking at that now too. 0, 0.
no, that's right, because you were doing 5, right? Because the 10 was from a different problem from before. So 5 in binary should be 1, 0, 0, 1. That's right.
1, 0,
Oh.
0, 1.
Because you did 5 divided by 2 because you wanted to use 5, and 10 divided by 2 is from a different question, wasn't it?
I think
No,
we were
no.
doing 2 or 10 to binary.
Yeah, 10 to binary. So 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1. remainder 0, 1 divided by 2 is 1. So it should be 1, 0, 0, 1, 0. I don't remember if I have to do, do I do, I don't remember if I have to do the two's complement of this. Let me see. 1, 0,
I don't think you had to do any compliments.
I
Let me
like
check my
remember
notes.
this now.
It's to know complements in general. So if he asks for the complement of this number, then you do the complement.
Mm-hmm.
I'd assume.
But why did I get a different result here? So
I
this
don't know. That's what I'm looking at. I'm like, what the hell?
2, 4, 8. I messed up something over here.
Oh, is it the 5 divided by 2?
It's 5 divided by 2.
It's not 4.
5 divided by 2 is
Oh,
2.
my bad, yeah.
Yeah, I just noticed that.
That's 2 because 2 times 2 is 4.
Yeah,
and
I'm
then
like, what
Yeah.
and then
the?
here's
Okay.
2. Yeah, that was my bad. Yep. This line doesn't exist.
Yeah, I'm recording it externally on OBS just in case Zoom decides to crap itself.
So then. Oh, okay. So the 4 doesn't even matter because you would go to
No,
2.
I messed it up. So
Yeah.
you get 5 divided by 2. 5 divided by 2, 5 is 4 plus 1. All of this divided by 2 is 2 plus a remainder of 1 over 2. So this is where I messed it up. I wrote a 4 over here for some reason.
And so 1 0 1 0.
Yeah, and then you write, and then you read this down up. 1 0 0 1.
And then you divide by 2 because it's binary.
Yeah, you
Or-
divide it by the base.
Yeah.
Base
So
2
if
is
we were doing
binary.
octal, you divide it by 8.
E.
Yeah. Okay. Sorry for the dumb questions. I'm like,
You're good. You're good. It's good to know what to do because if you don't do it on the test right, then it's final.
Something
Yeah.
that always helps me with remembering notation was putting whatever number it was in parentheses and then putting the base at the bottom. Because he didn't have that on the study thing that he was sent to us on email. But he'd probably have it on the test that as an easier notation to remember which base it's all in. Because it's very easy to get mixed up otherwise.
Right. And the good thing about hex is just to keep in mind it's shorthand binary. So as long as you have the I mean, you could technically do it binary to hex, but I don't know. It's another preference thing.
Right, so let's move on over here. So convert FA to octal. So you guys remember how to do it, right? How to convert hexadecimal to binary, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No 10. 11, 12, 12, 13, 14, 15. These numbers over here, they don't exist. So we need new symbols for them. So because these numbers, they don't exist, we call them,
letters.
yeah, A, B, C, D, E, F. So 1 is 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Letter 8. Number 8. 1, 0, 0, 0, 9, 1, 0, 0, 1. So letter A is 1, 0, 1, 1. And this last one will be 1, 1, 1. So we want to know F and A. So FA for binary. Let me remove all the other stuff. Out the way. So these are the numbers that we want.
One zero one.
So FA is gonna be, the letter F is 1, 1, 1, 1. And then the letter A is, or number A is 1, 0, 1, 1. 1, 0, 1, 1. Now octal works with threes, we want to group them in groups of threes like this. So we're missing one number here, so that's 0. So in octal, we go from 1, 2, 3, 4, 5, 6, 7, and then 8 is the number 0. So 0, 0, 0, 0, 0. Oops, there's no. I always go one past one. 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1. So 0, 1, 1, 0, 1, 1 is over here, 0, 1, 1, so this is number 3. 1, 1, 1 is number 7. 0, 1, 1, 0,
1,
1,
1, 3.
number 3 again. So FA in converted to octal becomes 373. Does that make sense?
Okay, so
I don't think that's
Just-
right. Isn't A 10? Shouldn't it be 1010, not 1011?
1010. Let me see.
Because 1010 is
A
8
does
and 2
equal
is
10.
10. And 1011 is B, which is 11. So it should be 383 or 373, sorry.
So remember to not make things too fast because you're gonna make mistakes.
It's okay, yeah.
Small two binary chart. It's good to know how to.
It's
They
good
write
you guys
this
are
stuff.
catching it though.
Yeah. So this is 1010.
1,
Yeah,
0,
you're right.
1, 0.
So it's 1010. So letter A is letter F is 1111, and then it's 1010. This is 0. Then
1, 1, 1.
because
1,
we
0.
went back one number, so there's a 2 over here.
Yeah, so it should be 372.
372. That's right.
There we
1,
go.
2, 3, 4, 5, 6, 7, 1, 2,
Oh.
3.
Same thing, same exercise. Let me erase this too.
Oh, and then, okay, so you put them in groups of 3, and then if one doesn't make a group of 3, you just have to add on the zeros.
You add leading zeros.
Yeah.
Because leading
Okay.
zeros mean add no value. They're just space.
Perfect. And then you just convert those numbers that you get from there.
Yep.
Exactly.
Okay.
Everything kind of goes through binary when you think about it. When you're kind
Yeah.
of converting everything.
Binary
if you can get to
kinda holds it
binary,
all
you could probably
together.
get to everything else.
Now
It's
we want to
essential to
convert.
know how to convert to
ahead.
binary.
Now we want to convert this number over here to decimal. So you guys remember how to do it, right? So this is 2 to the 1 to the 0, 2 to 1, 2, 4, 8, 16, 2, 4, 8, 16, 32. So to mark them. Let me mark them. 2, 8, 16, 32, 64 plus 128. It's good to have memorized. Do you guys have memorized the powers of 2? It's good to have them in your head.
Yeah, so it's just easy.
Yeah.
They're useful. So this number is the number we have. I have no idea what this number is.
I think it's 250.
Let me see. 128.
Time to get the programming calculator out. I always use it to double check.
1, 2.
Yep. This is
Okay.
250. Right.
Okay, I'm starting to get it. So you just like pretty much say F the zeros and then you only do it to the ones.
Right, because the ones are the only ones that are on. so
Yeah,
they're the only
and
ones
the
that count.
zeros don't matter. They're just spaces. Holding.
Exactly.
Okay.
So this actually means like something like this. Times this over here is times 1. This 0 means 2 to 0 times 0. This 2, 0, 1, 2. 2 to the 2 times 0. This over here means plus 2 to the 3 times 1. So that's why you count only the ones and you ignore these ones because they're times 0.
Okay. Got it.
Right. Now we have the task of getting this number and converting it to hexadecimal. So you guys know the answer, right? So we need to figure out
Yeah.
this number into hexadecimal. So we divide it by 2. First we convert it to binary, so we divide it by 2. So 250 divided by 2. Divided by 2. It's 1, 2, 5. Remainder 0. 2, 5 divided by 2. Equals 63. Remainder 1. 63 divided by 2. 63. 63 is a way for you to never get lost in this is writing 62 plus 1 divided by 2 equals 31, remainder 1. And then 31.
So wait, why do you add the 1?
Where?
Like you did 62 plus 1 divided by 2.
So every time you complete this operation, this number goes over here.
Yeah.
This goes over here.
Mhm.
This number goes over here. So for you to not get lost, you just write this number, you make it even. So you see this, it's even.
Mhm.
So the 62 turns into 31, the remainder 1 over here. I could
The
have
plus 1 was just to make it easy because instead
Yeah.
of dividing by odd numbers, you could divide by an even. And then
Okay.
get an actual number and then have the carry that you already know is going to be 1.
plus 1.
So
Or not
basically,
carry,
the
actually.
plus 1 there is just to show you that that came from the 63 after we rounded it down.
Yes.
Because
Okay,
it's supposed to only just be 62 divided by 2, but it's supposed to help you conceptualize it.
So you see the 31 here?
Mhm.
So let's turn this 31 into a 30 plus 1. And now divided by 2, that's 15, remainder 1. So 15, 1, 4 plus 1 divided by 2 equals 7, remainder 1. 7, 6 plus 1 divided by 2 equals 3, remainder 1. 3 equals 2 plus 1 divided by 2 equals 1, remainder 1.
And
1 divided by 2 equals 0, remainder. So 250 is this much numbers. So it's
so 1, 1, 1, 1, 1, 1, 1, 0.
1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
2, 3, 4, 5, 6, 7. I think I messed it up over here.
Yeah, you have a 4 that shouldn't count.
Let me see.
It should be the third one from the top should be a 0.
This one should be a 0, right?
The third one from the top. Yeah, because it should be, yeah, the one you underlined.
0. So this should be,
I think it's probably easier not to do the number plus whatever. I think it starts to
Yeah.
confuse people.
Because I just assumed, like, I guess the plus 1, like, I don't even look at it because I feel like if you just get a remainder, like,
I think the remainder is fine just to keep for the end when you have to, write the binary number backwards. But just in the like case of like, oh yeah, it's 62 divided by 2 is 31. Then you just put the 30 or whatever number that it comes out to if there's a remainder or not. I don't think you should keep the 1. I don't know. Because when I have the 1 there, I kind of get confused.
yeah, me too. That's why
Honestly.
I like.
do whatever way you feel the
Yeah.
best for you. This is just the way I used to do.
E.
Um,
That's fine.
why did I get it wrong?
250 divided by.
The 6 divided by 2 is 3 remainder 0. I think.
This one?
No, wait, no, wait.
No,
Hold on,
it's-
I'm
Yeah,
trying
because
to,
you add one.
I'm trying to
so
find
it's
where.
so when you start from top, 250 divided by 2,
Yeah.
125, 0. Divided by 2, 62.5. Remainder 1. Okay. Divided by 2, 31 remainder.
62 divided by 2.
Shouldn't it be
Has no
62 with the
remainder.
remainder 1 instead of 63 remainder?
62 divided by 2
That
is
one
no
too high?
remainder.
Oh, this.
No, 62 times 2 is 124. So then you have the remainder 1 is 125. The 63 should be a 62 in the second one.
Yeah, 62 over here, and then this is plus 0.
To figure out.
And
Right.
then this is
And
this.
that's where you get the 0.
125 divided by 2. Yeah.
Oh.
62
And then all the rest are the
divided
same,
by
so
2.
alright.
Yeah, that's where it was. It's the 30. Yeah, you got it.
Yeah, because it comes out to an equal number, right?
Yep.
Let me just
So
confirm
this-
Okay,
really quick.
so
And then you write from bottom up, so this becomes 1, 0, 1, 0. And now we group these numbers into groups of 4 since we're doing hexadecimal. And as we saw before, this over here is an F, and this over here is an A. So all of this is how you do this one.
in groups of 4. So I'm just writing it down fast.
Everyone good?
Yeah. Yeah,
And
big
then-
thing is like don't get scared by hex because it's literally just a shorthand of binary. I used to get scared whenever I'd see like a letter with binary,
Yeah.
but no, it's literally just shorthand. So
Yep.
So let's move on. This thing. Do you guys know how to draw this thing?
I need to write it down so I have it like somewhere to just keep on looking over it.
Oh, a decoder.
Yeah.
Yeah.
The decoder was the multiplexer without the OR gate, right?
It's
It's the-
the inverse of a multiplexer, I thought.
Oh, that was the demultiplexer.
Oh shit, yeah, sorry, I'm thinking the wrong thing. Oops.
Okay, so the decoder is gonna accept 2 inputs from what I remember. I don't know if this is exactly correct. So it's S1 and S0. Those are the 2 inputs. So the only possibilities that these 2 could be is 0, 0, 0, 1, 0, oops, 1, 0, and 1, 1. Let's draw it. This is S1, S2. 0, 0, both are false. So this is false. This is also false. Okay, do you guys see this over here?
Yeah.
Mm-hmm. Sorry.
Next one. This one is 0. And this is 1. Next one. 1. And the other one is 0. Oops. This one is wrong. This one's actually
Yeah.
right. And then both are true. Both are 1. Now we plug all of this into AND gates. And all of this over here is our decoder. This is the basic structure of a decoder. So from this, let's do some magic. Now we have this decoder, and we're gonna turn it to a multiplexer. So we're gonna take all of this, and you're gonna turn all of it. It's gonna accept multiple inputs. All of these inputs are going to go straight into the AND gates. And all of the AND gates will output into one input. This is output. I don't know what the letter they use here, but this is the output. So this is a multiplexer. Does that make sense?
So the thing they all connect to is the multiplexer.
It's an OR gate. The whole thing
Yeah.
all together, the decoder and the OR gate, is the multiplexer.
Got it.
Now you go ahead.
No,
The
I'm just
entire
done,
thing
I'm
is
sorry.
technically a multiplexer, but
Yep.
yeah. They all go into the OR gate, so it could be either one sets it off,
Yes.
depending on your inputs.
Yeah, the whole thing is a multiplexer. Exactly. It's just easier to see separate parts. You see like this part and then this part on top of it. It's
Oh yeah,
easier
for
to-
sure. Yeah.
Now let's do a D multiplexer. So the demultiplexer does the exact same thing, but it's gonna take one single input.
Oh, and then the multiple. Oh,
Yep. Takes one single input. And then outputs is the demultiplexer. So you guys can see here, this is the decoder, this is the multiplexer, and this is the demultiplexer.
perfect.
Awesome.
Feels weird and hard, but once you get this basic structure over here, it becomes very intuitive to make everything else.
Yeah, it's very important to know the architecture of all these different circuits, because I would assume would come back to them in my architecture, the digital electronics course I took, which is very similar to this. We kept on coming back to this after like the first semester of it. So I would definitely remember these.
Got it. And yeah, that's why he told us to just remember like one or the other or something like that, and then you can just
Yeah, if you know the multiplexer, the demultiplexer is basically the inverse. So
Yes. So you see multiple inputs here, and then one output, and then
the other one's literally like flipped.
Yes,
Yeah.
exactly. One input,
Okay.
multiple outputs.
Okay, that's
sometimes-
not bad.
And sometimes you can connect them. Can you see? You can see my mouse, right?
yeah,
So you can connect all these into like over here, and then make this one whole thing. Or
yeah.
the
So the
reverse.
red line going there would be coming out of the multiplexer.
Yeah. Or the reverse. You connect this output over here, and then you have these two connected together.
Yeah.
Okay, so you guys know how a full adder works, or have some idea, or need help.
Know how it works, but yeah, it's also that like architecture thing. Definitely want to have that written down.
Right, so let's have some addition over here. 1 plus 1, okay? When you, if it was 1 plus 0, what would be the output?
1.
1. When it's 1 plus 1, what's the output?
0 carry 1.
0. Yeah.
0 carry 1. So this behavior, 1 plus 0, 1, and 1 plus 1, 0, this is the behavior of an XOR gate. One or the other, but not both. Not both. So we start with an OR gate, one or the other. This is the worst OR gate I ever draw.
Okay.
Are you using a mouse?
I'm using a pen.
Oh, okay. Yeah,
So
it's
you
a
have an
little
OR
hard.
gate. You have the OR gate because it's one or the other, but not both. So this is an exclusive OR gate. And we have two inputs, input A, input B. Now we have this output over here. This is an output. Anything that happens over here is an output. So this is an output, and this output says over here is 0. So one or the other gives 0, and both gives 1. What is this behavior?
Can you repeat that again?
Yeah, I don't know.
We have these are outputs, okay?
Yeah.
1 and 0 give 0. 1 and 1 gives 1. What's this behavior?
1 and 1 gives 0. And
I don't know. I just keep it like adding, like what we've always done.
Yeah,
I guess I don't know what it's called.
You always do this, and you don't realize that you do this intuitively.
Yeah.
1 or 0 gives 0, and 1 gives 1. This is an AND behavior, right?
Mm-hmm. So you have both for it to be outputted.
So you need an AND gate over here.
Is this okay? I'm just trying to like remember from the lectures.
Does this make sense?
Yeah, is this the one where both of them have to be like 1 to pass, right?
Say it again.
So for
like
yeah,
both of them have to be 1 to pass through.
For an AND gate, yeah.
And then is the OR gate the one where it's just one of them needs to be 1?
Yes.
Right.
Oh.
Or
An
both
OR
of
gate
them.
could be or both.
Yeah,
The
yeah.
exclusive OR means only one or the other.
Mm-hmm.
Okay, so okay, it's kind of piecing together. Sorry.
And this goes into an OR over here. I don't know how to draw OR gates, guys.
I do a curved line and then just kind of make a triangle at the top.
Yeah, it's curved line, and then you kind of want to like curve them into each other at the very end of the gate, because it's technically curved with a point.
I hope he doesn't care.
I'm sure he will, because he seems like the kind of guy who
As
will
long
points
as
for words.
As long as you make the exclusive with a line behind it, and then you make the OR also curved in the back, but like not an additional line, you should be fine. Because the curve and the flats are essential for differentiating ANDs and ORs, and then exclusive has the extra line behind it.
Yeah, if you want to be safe with the OR gates, just draw a triangle with a curved base.
That too, yeah.
Just make it as obvious as possible that it's different.
Okay.
I mean, you can also just put next to it like AND gate or gate.
Put it inside, right? And
Maybe you get
capital
extra
N.
credit.
This is also new to me. It's like insane.
Yeah, it's a lot of content.
Yeah, if you don't have discrete math before this class sucks.
I'm literally, like I said before, I'm literally in trig. Like, I don't know how I'm in
Oh, yeah. Yeah, this class is going to be a bit of a crap show until...
I mean, if I study, I think I'll be fine. It's just brand new, so I'm like... Ugh.
Yeah, it's a hard concept to get down the first time.
Yeah.
It's a lot of information. It's kind of like an information dump, and it's all a little bit abstract.
Right.
Yeah, I was telling someone earlier, I was like, I wish we had, as dumb as this sounds, like, I wish we had more homework. Like,
yeah, we've had one assignment all semester.
It's scary.
We should make our own like homeworks and just kind of pass it out. Just like, here, we're gonna be doing this today. I wouldn't mind doing more sessions. I honestly wouldn't care as long as people want to go to them.
Yeah.
Mm-hmm.
All right. So, do you guys realize that this? You guys realize that this structure over here, when we do addition, is the exact same structure this one over here?
Yeah.
Has 0, 1.
Yeah, the exact same thing that you do over here is the exact same thing you also do over here, right?
Mm-hmm.
So the exact same thing we did over here is going to repeat. So let's say this is A and B, this is going to be C and D. Jesus Christ.
Also, with the he told us he's always going to give us the number of outputs no matter what, like when with inputs and outputs. So we're never going to have to use that like 2 to the n formula. At least that's what he told me when I asked him.
I think it'll be helpful to know just in case, but hopefully you're right.
Yeah, because like we have the practice problem, and the 2 to the n was wrong for the number of outputs he like wanted to do. So that's why I asked him.
So do you guys see that when we have a carry on over here, let's say 1 plus 1 yields another a carry on over here, we add them to the next operation. Do you guys see this? So this means that this operation will include the carry on of this operation, of the previous operation over here. So we get the previous operation, which is the carry in over here. And then we XOR again. And then we do the exact same thing, one or the other, but not both.
Oh, and this is where we get to connecting and everything.
Yep.
The carry out of the previous is going to be the carry in of the next, and the carry in of the first is always going to be 0.
Does it make sense?
Yeah.
And that final output of the XORs is going to be the sum on the top right.
Yep. So the output over here of the whole thing is going to be, let's say here we had 1 and then here we had 0. So the output of this circuit. And then we had 1 left over here. So this would be the leftover over here.
Okay. Trying to find a specific problem I didn't understand. I highlighted it. Oh yeah, okay. So we have to know how to draw these in the box level too, I'm assuming.
Yes.
Yeah.
But that's not much different, honestly.
So the box level just
I
draw
think it's
like,
easier. It's less drawing.
Yeah. It's like 3 boxes. Well, it depends, I guess, but
and then you draw like something like this, 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 and then this over here is going to be the carry out that comes over here. And then you get this number, which let's say we add 11 to 10. So this number comes over here, 11. Oops. This number comes over here, 11. And now this number, 10. And now we add them. So 1 plus 0 yields 1 plus 0, 1, carrying 0, 1 plus 1, 1 plus 1, 0, carrying 1. Now here we have nothing, 0, 0. So 1 carries 1, 1, 0, 1, 1, 0, 1.
okay. I'm looking for this problem.
You may also have to label the boxes FA for full adder. You may get super strict on that.
Yeah, I think you do.
And then on the first box, you may also want to label a carry in of 0 for the one of the top labels. Because I have no idea how specific he's going to get, but based on how he teaches in class, it seems like he's going to be really strict for no reason.
Yeah, definitely mark everything you can.
Yeah.
Literally like copy and paste.
Label everything.
Can we go over, like, do you guys remember the star, triangle, circle problem like we had?
That was
yeah,
just,
I actually have that written down.
Yeah, that was just to show you the concepts of converting like bases and stuff. Like technically you don't really need it, but I guess it'd be helpful to go over.
Because he told us this was going to be on the exam.
Oh, he told us the star thing would be on the exam?
Yeah.
Oh shit,
Because
yeah.
I wrote
Okay.
like all my notes I wrote like exam question for everything he said would be on exam, and that's one of them. And I
Yeah.
guess I just wasn't paying attention enough, and I just got lost.
It was just a pattern recognition thing where you
Yeah,
have
that's probably where I got fucked.
yeah.
I
I
will.
can take a picture of it and send it in the Discord if you want to try to
Yes,
explain it, and we can follow along.
I will
One
have.
second.
Unfortunately, I will have to leave because something's going wrong with my computer, and I have a lab. So
Okay.
Actually, I can just stream my screen.
Yeah,
If
you
you
guys
guys-
can all share your screens if you'd like.
yeah, let me stop sharing. So if you guys
Okay.
still want to meet like tomorrow, I want to do this something like this again tomorrow at 3 p.m. if you guys are interested.
3 p.m. I should be fine. That's a Saturday. I don't work until Sunday,
Saturday?
so
Mhm.
yeah, if I can make it, I can just record it again as well. Because right after this is done, I'm gonna be taking this video, putting it into my editing software, maybe clipping and adjusting the audio a little bit, and then it should be published to YouTube by like a couple hours from now. Because processing takes like an hour or so.
Mhm.
So yeah, that'll be up, and then if I can make tomorrow, I'll also record and publish that as well. It'd be awesome. But yeah, I should be good for tomorrow. I don't know what the rest of you.
Yeah, thanks. I see you later.
All right.
Thank you.
Later.
Good luck with the lab.
Thank you.
Okay, here.
Okay. Yeah, I don't know why the shape's just like really. It's definitely easy, like 100%. It just the shapes like I don't know.
Yeah, it's kind of a
But-
weird concept sometimes, especially
It's,
when
like,
you move
all
so
out of
fast.
nowhere.
We
Yeah,
move
out of
super
nowhere,
fast too.
I just look up and
Teaches
it's
all
like
over the
stars,
place.
stars and triangles and circles. I'm like, what is happening?
Okay, so it was a triangle, a circle, and a star. You guys can see it, right?
Yes.
Yeah.
Okay. Yeah, 0, 1, 2, 3, 4, 5, 6, and 7. And then he said, using symbols, try to make the combinations. So
Yeah.
we just start in order. So we could do like 0 is a triangle, 1 is a circle, 2 is a star. Although these values they kind of confused me at first. You kind of don't pay attention to the values. It's all about the patterns of the symbols.
Yeah.
Because
Okay.
when you're out of symbols, you restart. So what I mean by that is you start with the first symbol, and then you add the next symbol in front of that. And
So you
then
start with the first.
yeah, so like basically there was three symbols, right?
Yeah.
So there's only going to be 0, 1, and 2 have a single symbol. And then for 3, 4, and 5, they all have the symbol of the second one as the starting symbol. So all of these are going to start with a circle.
Oh wow, you did a much better job at explaining.
And then the pattern is that you just keep going down the line. So 3 becomes circle triangle, 4 becomes circle circle, and 5
circle.
becomes circle star.
Oh my god. Okay.
Yeah,
And
it's
then
so much
6
easier this way.
becomes star
Star.
triangle,
Triangle.
and then star circle, and then if we had an 8, it would be star star.
Oh my god.
Wow,
Okay, 'cause
when he
this
did
one
that
was-
the first time, it just did not like I wrote it down, but I didn't get any of it.
Yeah, I
it
wrote
was
it down,
it was
and I
hard
was-
to process at first because he taught it really weird, but hopefully that made sense.
A lot of the concepts he's been teaching have kind of been out of order. Like
So you
when he got to
literally- yeah,
logic
just-
gates, he started with the architecture of like adders, and then he went to logic gates, and I'm like, huh? It should have been the other way around. But yeah,
oh my
it's
God.
that was a lot better of an explanation.
It's just so weird. I don't know. I don't know why it's so weird to me.
Yeah,
It's like,
it was.
you really don't pay attention to the.
It was quite a interesting way of thinking about it.
Yeah.
It was like you take the second symbol and that becomes your leading one, and then you use the previous one and you just do the same repeating pattern.
Yeah, I
So
would
it
definitely
was
not have gotten
star
that.
circle. It was
Yeah.
triangle circle star, and then it was triangle circle star with the leading circle, and then it would have been triangle circle, and then another star, say like we had an 8, so it'd be star, star.
Okay, that's one exam question I marked. I'm probably just gonna compile them all together and then just like send out one document that just has all of them. Except for, well, today we didn't have really a lecture. Last class I wasn't there, so that's the only class I don't know if he asked one. So
Oh, I think, let me see, last class, I think there's one. No, I
yeah,
don't
that's
think
the
he's gonna
only.
do it though, because I think he's supposed to elaborate more today, and since he wasn't really there. Like the only
Did
thing
you
I
say the,
marked as exam that he said was like it was about the K maps, but he said that I don't think that's gonna be on there. So
hold on real quick.
Okay.
Are the shapes going to be on the exam?
Or the what?
The shapes.
shapes.
Yes.
They're going
I
to be on
mean,
the
yeah, I
exam?
have it marked down too because you said that that could have been on the exam as well. So
Yeah,
Yeah,
the
he's-
concepts
yeah,
of it
question.
definitely no, just in case he
Yeah.
throws it on there.
Yeah, he said it was going to be, so I'm just gonna assume.
I'm a
just gonna
bit
wing
worried.
it.
Like he's splitting it in 2 sections. Like how long?
Well, I'm sure the reason why is because he wants you to write down absolutely everything. And
Yeah.
so he
Yeah.
knows that it's going
Brain
to take you
dump.
more than just 50 minutes. So you got to give him credit there, I guess.
imagine he wants us to do the decoder for 8 of them, and so it's gonna
Oh
take a little
God.
bit.
Did
Yeah,
he
for
mean
size
8 or
4 and
did he mean
8.
size 4 inputs or size 4 gates? Because if it's 4 inputs, that's going to take ages, and 8 inputs would be like almost impossible.
Rest in peace, the paper.
Yeah.
Yeah.
My hands.
Well, I have it. I
cramping.
think he means like the 8 gates because like I remember he told us to do the one with
'Cause-
like
Yeah, 8 gates is 3 inputs, which is
yeah
totally
3 input.
doable.
Yeah,
I think that's what it is.
I think
Okay.
yeah I think that's because I have that like as an exam like marked there,
Yeah.
that specific one. So I think it might be that one.
Okay.
What else did he say? Yeah, I'm literally just gonna study everything he just sent in that email and nothing else.
Yeah, that's what I'm going through right now. Everything in the email. But he didn't say the shapes were in the email, though.
No,
Yeah.
he didn't. Yeah, I think it's just more like you saying like concepts of it. Like I just marked down everything he said in class, like the exam,
Mhm.
and
Because he's like, this will be on the exam. And I'm like, okay, write it.
yeah.
Yeah.
What else do I have marked down that I literally don't get at all?
K-maps weren't terrible if you need to go over that.
I'm pretty sure you said logic gates. Did you want to go over them, like their truth tables and their architecture, or do you think you have that now?
The logic gates. Let me see where.
I'll be
it
right
is.
back.
All right.
Honestly, at this point, I'll take any help. I'm just worried about. Literally the hardest thing to me in this whole thing, and it's probably sounds so dumb, is literally conversions.
Bro, that's the same thing right now. I'm on. It's
Like,
We
drawing-
can do
conversion.
more conversions if you want.
Yes, please.
Yeah, we can do more
because,
like,
conversions.
Like I can
drawing
do
these
converting
things-
like decimal to binary is like no issue, but like it's the hexadecimal and octal that I really struggle.
Like
Yeah.
drawing gates and everything's like actually kind of simple to me, but it's like when I have to convert numbers, I'm like, no. Which
So
is
we'll
probably
do we'll do B8 in hexadecimal, and we'll convert that to decimal.
All right.
oh fuck, I'm hitting buttons on my keyboard.
So 8 in so we're gonna go through binary because it's just easier to process step by step.
Yeah.
So we're gonna start with the right bit, and that's 8. So that is going to be 1000. And then B is going to be 1011 because B is the equivalent of 11.
Oh yeah, I think I need to memorize that where it starts off. It's like A, B,
Yeah,
C,
A
D.
is 10
Yeah.
and F is 15. So if you just remember A is 10, you just count up from A.
Okay, yeah, that helps a lot.
Let me pull
Yeah.
up my
Because
shit.
for hex, you cannot reuse the 1 from before. You'd have to use an
Yeah.
A to represent
Right,
10.
because there's not enough digits.
Yeah.
Eight,
And then the same baseline is hex is just shorthand binary. So if you have the binary to hex conversion, it's pretty easy sailing to the other bases of like decimal and octal.
Yeah, so 8 is 1000 and B is 1011. So altogether, the whole string 10111000.
10.
And this is what it looks like in binary.
So 101110. Okay, yeah, because you just combine them.
Right. Because each digit is just a string of 4 bits.
Yes.
And then
And then-
from here to decimal, you can just add everything together with a 1. So this would be 8, and then 16, and then 32, and 128. Sorry, my handwriting is terrible on computers.
Yeah, it's a little difficult.
7. I need a calculator. I'm like stupid.
He's allowing a calculator, right?
I sure hope
like-
so. If not,
I
this will
like-
take me a little while.
Yeah, like I could do it by hand, but like it just makes him so much easier.
Really don't want to.
I think he said we could have like a simple calculator, like
Probably like a scientific.
not scientific, but like literally just ones for like adding and subtracting and stuff.
What's
I hope
the
we allow
decimal?
scientific. I don't have a basic one.
Yeah, I don't have a basic one either.
Wait, what are we
I just
converting?
add them.
We were converting B8 in hexadecimal to binary, or sorry, to decimal. Yeah, I totally butchered that. We're converting B8 hexadecimal to its decimal counterpart.
Oh, we
Yeah,
convert
so-
to decimal as well? I thought it
Yeah.
was just hexa to octal, and octal to hexa, and then to binary.
You're gonna need to know binary, decimal, octal, and hex.
You're gonna
So
know how to
make sure you
convert
know all of
between
them.
all of them to each other. Even if you didn't put it on the announcement, I would still know it anyways, because
Yeah, I got 184
these conversions
as well.
are the foundation for the class. Same with the logic gates and truth tables. Like, all of that's foundation, and if you don't know that now, after this exam, it's going to be very difficult to stay on
Uh-oh.
top of the class.
See if I can move over here next then.
I figured out how to do octal to hexadecimal, hexadecimal to octal.
Yeah.
Mhm.
I got. Can you show me how to do the decimal one? I was out in when we converted to binary, like you know how like with octal to hexadecimal you'd split it in 4s, and how with hexadecimal to octal you split it in 3. What would we split it in for decimal?
Decimal is
Decimal,
still
everything is
split into
singular.
4. Because
It's
you
split
would,
into 4.
yeah, you would take octal, put it into binary, and then binary to decimal.
Oh, so
Technically.
it's the same thing. It's
It-
the same thing
for
when we
me,
convert octal to hexadecimal.
You can do it different ways, but for me, I found it easy to take all bases, convert them to binary, and then move it to other systems.
Yeah,
You
it's
can
much
do-
easier to look at.
You can do it the other ways, but I don't know. I find that my answers are more accurate if I do it that way. I don't have
always
to
do
worry
it
about
through
messing up.
binary.
Yeah.
Mhm.
No, but I'm
It's a good
saying
thing
like
to do.
so like to convert from octal to hexadecimal, you have to like change it to binary, right?
Yes.
And then you have to split it in 4. So 1
Yes.
0 1 0, that's 4. And then from there you get like let's say 10 15 3. You change 10 and 15 to A and F, and then 3 stays the same, so it's AF3.
I don't know if I
That's
followed
octal
that
to
exact
hexadecimal.
example, but binary is shorthand. Sorry, hexadecimal is shorthand binary. So as long as you have binary and you split it into 4 chunks of each, you can easily move it to hexadecimal.
Yeah, that's how I did it.
Yeah.
But like to move it to decimal, is it the same as moving it to hexadecimal just without changing the numbers to letters?
Technically, because when you have the binary, you don't actually have to split it into 4, because for decimal you have to add up the base 2 conversions. So the 1 0 1 0, that's 10, right? Well, if you add a 1 on top of that, it's going to be 16 plus 8 plus 2. It's different from converting binary to hexadecimal, because decimal you have to add up the base 2s of each index. I don't really know the best way to describe that with only using words. I'm usually very visual through writing it, but we can probably do an example of that if that would help.
Well, I'm
You.
doing something real quick. I'm gonna try it with convert octal to decimal. Hold on, let me try doing something real quick,
Okay,
and then I'll let you know if I got it.
So you're converting 234 in decimal to back.
Yeah, what are you converting decimal to what?
Was it to
I'm just going to
hex?
convert it to everything from binary,
okay.
hex, and octal. That way we can use it as an example. So this would be 0 1 0. So that's 1. 1 and 2 is 3. And that's not right. Hold on. 2 4.
I think your binary is also wait. What do you? Oh. So for binary, 1010 is 10. And 111 is. Wait, what is happening? I'm so
Yeah, I think
confused right
it's
now.
wrong.
I'm so.
I'll double check it. Hold on.
Yeah.
Because I'm sitting here like, what is happening?
Do I have anything? I have like Microsoft Paint. I guess I could use.
No, that's right. 128 plus 64 plus 32 plus 8 plus 2 is 234.
Yeah, I mean when you're sectioning off those two things there, that's what I'm confused about. Because you put 7 and you put 5.
I think the 5 is wrong. I think I mixed that up.
And the 7's wrong, because 7 is 0, 1, 1, 1.
You're right.
Wait, so you just put 7 and 5 together rather than 7 plus 5?
No, so the 7 and 5 that he put were wrong because those 4 chunks are actually different numbers. So the one
the
on the
wrong
right
numbers.
is going to be 10, and the one on the left is going to be 14? No, I can't count. Is that 14? 8 plus 4 is 12, yeah.
$14 is E, so it should be EA.
Sports.
It's in the game.
And then you'd have to.
It'll literally take me like an hour. Just kidding, maybe not now. But...
Hey, after this, can we convert the octal 5363?
Wait a minute. I'm trying to make sure this is all right.
So we don't have to add the leading 0 in front when doing it to binary.
The only reason you would add leading zeros is if you can't section things off evenly. So like when I was doing the
Okay.
conversion from binary to octal, I had to add an extra leading 0 right here
Okay, I see.
because that way it could be 9 digits instead of just 8.
All right.
It's just easier for visualization.
0, 1, 0, 1, 0, 1, 1, 1, 0. Okay.
But I think this is all right.
Oh, it's going to be 352. The third bracket.
Yes, you're right.
Yeah. I was like, you're off by 1. I don't know why. And then I'm like, oh, there it is.
You're converting hexadecimal. I'm sorry, not hexadecimal. Binary to not binary. Decimal to octal in this case, right?
Yeah.
Okay.
And we just showed the extra step of also putting decimal to hexadecimal there with the EA. Because technically you don't really need to find the hexadecimal unless you ask for it.
Okay.
You could have just gone decimal, binary, octal if you wanted to.
Yeah. So if he said, hey, here's 234, change it to binary, you would do this. If he said, do 234 to hexadecimal, you would do that first step to binary, and then you would end up getting this. Or if he said, do it to octal, you can just do the first step to binary, and then you'll end up getting this one over here on the right. Either way, it's just the easiest way to do it is just always go to binary first, and then change that to whatever you need to.
Do you guys want to do another one?
Let's do 5363, which is octal, and let's convert that to decimal.
363.
363 and octal.
Okay.
5363.
5363.
Yep. Octal, and I want to convert it to decimal.
Oh God, good luck. It's a lot of binary.
Okay, so 3 is going to be.
Okay, 5 is 101.
I wonder if it's easier in this case to do the divided by 2 method.
It might be.
Unless you know that many placeholders for base 2.
Okay, so 5 is 101, 3 is 011, 6 is 110, and 3 is 011. I just do the divided by 2 method. That's how I do everything.
Yeah.
Yep.
That's what
So
I'm
this
just
is-
doing because it's easy.
I don't memorize any.
It's
any
much
of
more
the-
streamlined.
Yeah, I don't memorize any of the decimals. There's no use to doing that.
So this is what it looks like in binary.
Mhm,
And then
now
from
gotta
here,
split
you
in
just
fours.
convert it to decimal. So you would get 1 plus 2, 4, 8, 16, 32,
Oh, you don't gotta.
64.
You don't gotta put it in fours then.
No. I mean,
Oh,
you
what
can
the
if you
heck?
want to, but you don't have to.
Putting it in
No, I did it
fours is
wrong.
better visualization, I guess, because you're chunking it up. But
Yeah.
for just adding these bases, you don't really need that because you're just going in order. If that makes sense.
Yeah, it makes sense now. That's what I was doing wrong. Okay.
Somebody double check my positions. I think that's all the numbers you're supposed to add up.
1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1, 0. Yeah, that should be it.
Okay. Then adding up all those numbers together.
Is there also people
Believe.
that want to go through and do the divided by 2 method just so you're solid on it, or do you guys understand that already?
Yeah, I
I don't
think
know.
we
I
all
just-
I'm
understand.
pretty good on that one.
Okay.
Yeah, the divide by 2. I just like you could all. Well, hold on, let me think how to say it. Dividing by other numbers other than 2. Would that happen?
Only if you're doing different bases.
Yeah.
Yeah. Okay.
The dividing by 2 is because you put it into binary.
Yeah, that's only because of
So
binary.
could you use that method for any of the others or no?
You could. I don't know if it would be much easier or more difficult, but you could definitely try.
That's normally what I do because like I said, I go from binary to other base systems.
Okay, so no matter what, it's like a good like hook point or setting point to like always convert it to binary and then go from there.
Yeah, because you can always do an easy conversion from binary to any of the other ones.
And then converting
That's
it to
in my
binary
opinion.
is just dividing it by 2 if you don't know, obviously, if you don't know
Pretty much,
the
yeah.
numbers. Okay.
Only case would be hexadecimal. I would not do that with hexadecimal. I would convert hexadecimal just to binary from the shorthand method, just splitting it up and writing out in binary.
Honestly, he came over to my paper in one class and he didn't like how I did this because I just remembered all of the positions. And like I just
Yeah.
remember that each one of these is in groups of 3.
Yeah.
So like when I go onto the test, I'm gonna have to put out more information than just remembering what each position looks like.
Yeah.
But so that's what's nice for the dividing method. But you may want to double check your work if you do the dividing method or if you do this method, whatever it is, just to make sure you're not messing something up really fast. Because it's very easy to get mixed up.
Unless he if he specifically says to do it a certain way, then that's going to be very difficult. Because not everyone memorizes the one way to do it.
Yeah. Because each bit in octal is 3 bits in decimal, and each bit in hex is 4 bits in decimal. And then for just converting from decimal to, or from binary to decimal, I just remember the powers of 2. It starts with 2 to the 0, the next one to the left is 2 to the 1, 2 to the 2, and you just keep going. And then you add where all the ones are.
Yeah.
Wait, can you repeat that one more? Like, what was that one for again?
So when you're converting from decimal to binary, the way I do it is just remembering the powers of 2.
Oh yeah,
So
in the
like the one all
spaces.
the way on the right is 2 to the 0, which is equivalent to 1.
Yeah.
And then the one next to that is 2 to the 1. The one next to that 2 to the 2, and you just keep adding.
Yeah, so decimal to binary powers of 2, and then you just add them all up.
To make decimal and octal, all you gotta do is turn it back into into the 1010 and then split them all up in 3s.
Yeah, put it back to binary first, then split them up in groups of 3. Exactly.
Yep. And the hexadecimal, you do it by 4s. And
right.
then if
You
a
put it back
number,
to binary, split it up by 4s.
And if a number is between 10 and 15, you just replace that with a letter, like 10's A, 15's F.
Yeah.
Yes.
Okay. So the conversion is not that bad. It's easy to like get
It's easy to miss a 0 or a 1 when you're
I think
converting.
it's just
things.
practice because now that I've been practicing more, I seem more confident in it.
It's just
It's
easy to
definitely
get tangled in.
practice. Yeah.
Okay. Okay. So when it comes to conversion, I think I'm good then. I'm good with conversion.
Yeah, I
Okay,
feel a
so if
lot
we were putting this
better
to
on it.
hex, we would get 1 and 2 is 3. All ones is F because that's 15. And then 1010 is A because that's 10. So AF3 would be in base 16. That's hex.
All you gotta do is remember that hexadecimal, you have to always split the binary in 4s. Octal, to get the octal, you have to split it in 3s. And that's really all you have to remember for conversions.
Right.
And then if you want to just get decimals, you don't have to split anything. If you want to like go from decimal to what's the other one? Or binary to decimal, decimal to binary, you don't have to split by 3 or 4. You just got to do like basic conversion, like divided by 2.
Yeah, so like a good thing to remember is computers are strictly based off of binary, and octal and hexadecimal were only made for basically people in our fields to easily shorthand these methods. So instead of us writing out, 0 1 1 1 1 0 0 1 1, we do, A, F, blah. It's easier for us to visualize and conceptualize octal and hexa rather than using straight up binary. That's like the only reason why it's put together, and that's why it's a basis off of binary. If you know how to get to binary from any systems, you're all good to go. That's just how it works. Yeah.
What's next? One's complement. That's the ones and twos complements.
Should I? Because we did this at the very beginning. Should I end the recording, or should I just keep it going and just go through and edit everything together?
No, end the recording.
Yeah, honestly,
Yeah, you
whatever
can
easier
start
for
it.
you.
You know what? I'll keep it going. Just I could try to splice these footage together, kind of like if. Yeah, I'll probably have it conversions first, and then I'll try to splice it afterwards. I need to see how much footage I'm working with.
Let's do 32 minus 19.
Positive 32 minus 19. And do you want to do it in a ones or twos compound?
I think you have to do both.
It's good to know both. I don't know if we'll have to do both in the same question, but I'm
No,
sure we'll have a
because one's
question of each.
complement just means you change the negative. So like 19, you have to figure out the 1 0 1 0. One's complement means you flip whatever is 1 to 0 and 0 to 1, and then two's complement means you just add them together afterwards.
It's two different methods of adding.
Really?
Yeah.
Shoot, I must have.
Let's just go over this one.
Yeah, let's go over it.
Do one's comp first. So 32 in one's complement would be 1
Or for
0
us.
0 0 0 0.
Yeah, 5 zeros.
2, 3, 4, 5, 6, 7, 8. There we go. Put it in 8 bits so it's nice,
Mm-hmm.
And then 19
0 1 0
is
0 1 1, and then put like 2 zeros before that.
Wait, zeros. Whoa.
so this is positive 19 right here.
Yeah. So you got to make it negative. So you got to
For
flip
one's
the-
complement, since we're subtracting, we flip it, it becomes a negative 19. So 1 1 1. Actually, let's do this way so we don't mix it up.
Yeah, I just said that though. For one's complement, I just said like we have to flip all the zeros to ones and ones to zeros if the number is negative.
Yep.
Oh, so I had the right idea then. I thought I was like completely off.
No. That's exactly the right idea.
Yeah, you're good.
You said there's two methods of adding. I thought you had to use both. Like one's complement to make that into if you have a negative, and then two's complement to add it together.
No, one's complement is kind of just part of two's complement. Because
Oh.
the only difference is you're adding one in two's complement. You
Mhm.
flip the bits in both as the first step.
Okay, whatever. I still got the right idea, so I don't care what the difference is. I know how to do it. That's all I care about. If I know how to do it, I'm good. I don't have to memorize the definition. Oh, I hope not. Knowing it's on
Just
tag.
don't even put that energy out there.
Yeah, for real.
Hold
Imagine
on,
having
I'm
to
slow.
write imagine having to write the definition word for word.
I swear.
I'm curious if hold on, I want to double
Wait.
check how we do one's complement. Because if we have to do one's complement in always 8 bits, then
Yeah,
the
he said
number's
it
gonna be a
always
little
has to
different.
be in 8 bits. I
Okay, then the
remember him
number's gonna be
saying
a little
that.
different. Yes, that. So
One,
then we're
2,
gonna-
3, 4, 5, 6. Oh, that's why you added the other 2 zeros. Perfect. And then,
Right.
sorry, I'm just dividing them all by 2 right now because I want to know I can do it. So I'm just like slower. So I'm gonna be taking my time on this exam.
Yeah,
Yeah.
you're going to need to.
Yeah.
19
Easy to
divided
trip
by
up in
2.
a 0 or 1.
9.5. 9 divided by 2. Two divided by 2 is 1.
Okay. Okay, so this addition right here is 32 plus negative 19 in one's complement. So when you add up all these numbers, you get 0, 0 is 0, 0, 0 is 0, 0, 1 is 1, 0, 1 again 1, 0, 0 is 0, 1, 1 is 0 with a carry of 1. So then you get 1 and 1 is 0, carry of 1. 1 and 1 is 0, and you get an extra carry of 1.
And don't you have to add that now?
And then since it's 1's complement, this gets added over here as an extra 1. So this becomes 0, 0, 0, 0, 1, 1, 0, 1. And
guess I
this
just-
should be the final
Oh.
answer using 1's complement.
I guess I just did my dividing wrong. Let's see.
1101. Okay. 0, 0, 0,
If
0,
we want to
11,
double
01.
check, 32 minus 19 is 13. Let's see.
So for this, it always has to be in 8 bits, right?
Yeah, it's right. It's 13.
Yeah, do it always in 8 bits.
Even if there's no like, even if it's 32 plus 19, same thing, 8
Yeah,
bits.
yeah, for sure,
Yeah,
for sure.
yeah.
Because all you're doing would be adding leading zeros, which doesn't change the value. It just expands it.
Okay.
The zeros in front, like I had to add 2 zeros over here. I had to add a whole bunch of zeros. I had to add 3 over here and then 2 more for the 32. All these don't change the value of 19,
Oh, okay.
but it just expands it out in 8 bits.
Okay, that makes sense.
1, 1. Hold on. Wait, I already did it wrong. 0, 0. So zeros. Wait, why are they? So 19 would just be 10011, right?
Mhm.
Yeah, 10011 is positive 19.
Oh, and then okay, I was looking I was looking at negative 19 this whole time. I was like, what am I doing wrong? Because I thought it was 19. And then and then we're flipping it.
Right,
Sorry
then
if
you
you went over
flip it.
this. I was
No,
like,
it's fine. So
All
I
we gotta
started
do-
by putting down 19 and then adding the leading zeros to make it 8 bits. Because if you don't do that, your number is going to be wrong.
yes, yes, yes.
And then you flip all of the numbers for 1's complement. You flip all the bits. So then you
1,
get
2,
1, 1, 1, 0, 1, 1, 0, 0. And this
That's
is how you
negative
represent
19.
negative 19 in 1's complement.
Perfect.
So then you come over here to the middle and you add positive 32 plus negative 19, the thing you just came up with. And then you can see all that math. You just kind of put the zeros and ones together. And then when we come to the end here, we have 0 and then 1 and 1. So that means it's going to be a 0 with an extra carry of 1. And in 1's complement, you have to put the carry back at the other end, which is what we did right here. So effectively, if we wanted to spread it out, it would look like 0, 0, 0, 0, 1, 1, 0, 0, plus 1.
Plus 1, and then you just add the
And
1.
that's how
Yeah.
we got to this over here.
Yes, okay, perfect.
Now it's time to do negative 32 plus 19.
You want to do that in 2's complement or 1's complement still?
Whichever.
There's 0, 0, 0, 1, 1, 0, 1.
So you gotta do negative 32 plus 19, then negative 32 minus 19. You gotta do it all.
Okay, this makes so much more sense. Sorry, I was just like, I just worked slow.
That's fine.
I'm starting to like this. Just kidding.
So this is positive 32 in binary. Then flip it for one's complement. We do 1, 1, 0, 1, 1, 1, 1, 1. 19 is positive, so we don't have to change that at all. But we do have to figure out what it is. So that's going to be this. This is positive 19.
So, oh yeah, you already flipped it. Okay, I just can't read.
We add these together. So 1 and 1 is 0, carry 1. 3 ones is a 1, carry a 1. 1 and 1 is 0, carry 1. Same thing here. 3 ones is a 1, carry 1. 1 and all zeros is just 1 with no carry. And 1 and 1.
And that's just it.
And this is how we would represent negative 13 in
Just
one's
once.
complement.
Okay, yeah, okay.
Now it's time for the finale. Negative 32 minus 19. We're just gonna use the same number so we don't have to keep doing the divided by 2, divided by 2,
Yeah.
divided by 2.
Makes it easier.
Unless you want to do like negative 52 minus like 32.
And then you just take both of the negative numbers and then.
So we get solve this part first to help us double check our final answer.
So it's gonna start with a.
Yeah, because it'll be negative.
What's
So
negative 32
0,
minus
0,
19?
1, 0, 0, 0. It's negative 51.
Oh, negative 51.
Yeah.
Okay, so basically do what we did last time and just make most of them negative.
Yeah.
Exactly. We're gonna have to flip everything. So 1, 1, 0, 1, 1, 1, 1, 1, and then 1, 1, 1, 0, 1, 1, 0, 0. Because we're gonna be doing flipping them on both because they're both negative. And then you add. So we get 1, 1, 0, carry 1, 1, carry 1, 0, carry 1, 0, carry 1, 1, carry 1, and 1 with another 1 carry. So that'll get added back over here at the end.
So I remember like one time I got a 1 carry, but you just didn't do anything with it.
Isn't
That's
that for
with two's comp.
twos? Yeah, it's twos.
In
comp.
two's
Okay, that's
complement,
for
you
two's
ignore it.
complement.
Mhm.
Yeah, okay.
So then we can do one of these. So we
So
can
one's
visualize
complement, you
these.
add it back in. Two's complement, you just leave it
Yeah.
as the carry. Okay.
Better to add it back in.
Huh?
I said it's better to add it back in.
Well,
Well,
in
you-
two's
two's
complement,
complement,
Yeah,
you
for
don't add
twos, you
back in.
don't do that.
you just
Oh.
literally leave it.
Depends on what complement you're using.
Because I like added it back in and I got it wrong
Mhm.
because you're not supposed to. So you just really have to be sure, like if you're doing ones or twos.
Yeah, okay. So this is how you represent negative 51 in one's complement.
Shouldn't the last one be 1?
No.
The last number.
No, it's 10. I'm sorry, 0 because the one's
Oh,
being
okay.
carried
No,
over.
your carry
remember, this is
confused
flipped.
me. Yeah,
Yeah.
yeah, yeah, yeah.
I underlined this one because this one is the carry that gets put
Yeah,
back.
yeah, yeah.
Don't call it a remainder, whatever you do. Oh my god.
Oh
Yeah,
my
no.
god,
Because
yeah.
I called it a remainder, and oh my god, he like I just
5
Flipped his
points.
Yeah, I
shit.
remember.
it was
Minus 5 points.
5 points.
never a remainder. No, don't even say that.
Honestly, if you
If
say
you get
one wrong thing, Montagne will like grab you by your throat and just like throw you across the room.
send you straight to hell.
Oh my god.
So this is literally hell for like computer architecture.
Okay. Yeah,
We want to
I
do
also
something in
think
twos now. Twos complements.
Yeah.
yeah.
What numbers do we want to do? Still 32 and 19. Give it a shot.
Yeah.
Sure.
Wait,
Yeah.
if we do it in two's complement, will we still get the same answer?
No.
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 Oh, so it'll be a whole
Sadly.
different answer.
Yeah,
Yeah,
the
'cause
binary
you-
answer will look different.
So which one's
Yeah.
Montagne gonna want?
Which
Probably
whatever he
both.
asked for.
Yeah, he's
Yeah.
gonna ask for
Both.
one.
He's gonna do one of each for sure.
Or he might give you one thing to do and then put him in both.
Yeah.
I can probably see that. I don't know.
Well,
Yeah,
in the
to save time.
exercises,
Yeah.
he gives 4 examples, and he wants you to do one's complement and then two's complement with both, with all 4. So
Yeah, because for practice.
yeah, so I'm gonna actually go through this whole study guide, whole
Practice
thing. Well, I guess we're doing
document
that.
thing.
Yeah, I'm kind of glad though he at least let us know exactly what's gonna be on there.
I
Yeah.
know.
I'm a bit worried.
He didn't mention anything about Marie. I don't think.
No, he didn't.
I hope not.
What did he put on the thing? Hold on, let me look at his announcement really quick.
So
I
like,
think we need to know the definitions of compiler and assembler, the difference between the two.
No, that's easy.
Yeah.
Yeah, of course.
Yeah, no, all this is like architecture slash conversions.
when we're drawing the circuit, the adder, the decoder, the multi.
He basically threw out like the first, what, 2 chapters? 3 chapters? He threw out a lot of content with that. About Marie and stuff.
Wait, so when we draw the circuits, the adders, decoders, everything, like, do we have to like put in any numbers to there, or do we just draw the circuits themselves?
I think it depends on the question. He could ask for like if he gives the input.
He
Damn.
better not. Please don't
so
do
good.
that.
I love
I'm
how he's
so
like,
good.
oh, you could design it perfectly, but if you get your inputs wrong, it's all wrong. I'm like, oh well.
Damn.
Like I know how to design them now. Like I can draw them like, but I don't want anything else.
Okay, since we already know what they are, you wrote them down, and then hold up.
If only this
Um,
class could be easier.
for real.
Honestly, the first couple of classes, I had no hope, but it's gotten better.
No, it's definitely gotten better because as like the course like goes on, he reviews the content and then he somehow like pulls crap he never even taught us like out of the blue. Like, oh yeah,
Yeah.
this will help you understand the concept that we taught last class. And I'm like, why didn't you teach it going into the last class?
Yeah.
It's kind of annoying,
Okay, so
but
this is how you do this question in two's complement.
Okay, can you
So-
walk us through it? Yes.
Yeah, so 32 minus 19 is 13. You can figure that out using regular numbers.
Mhm.
This
Mhm.
is 32 in decimal. This is positive 19. This bottom one is
Mhm.
positive 19.
Wait, so what's the main difference between one's complement and two's complement? Then?
Right here, we're gonna
Yeah,
do it right
yeah,
now.
he's gonna show
So
it now.
the reason why I wrote this out in positives first is because when you do two's complement, you flip it just like one's complement, but then you add 1 immediately. So you flip all these numbers over here where we got negative 19 to positive, or sorry, positive 19 to negative 19, and then you add 1 because it's two's complement. So this is negative 19 in two's complement.
So how do you know why would you only that's probably dumb. Why would you only add 1 to the positive one? Because you want to make it negative? Or
You add 1 for two's complement. It's something with the way two's complement works. The exact description I can't remember off the top of my
yeah.
head.
But like why wouldn't you add 1 also to 32?
Because
Well, because
32 is
32 is
positive. You're not
positive.
flipping
Okay,
it.
so yeah, you're only adding it 1 to
Yeah,
Okay.
these only apply to negative numbers.
Yes.
Yeah.
Okay.
If you need to
that's what I was
flip, then
thinking.
you need to add in two's complement. If you need to flip, then you just
Okay.
it always goes by whether it's negative or positive.
So if
whether or
it's
not need to
negative, you
anything.
flip it and then you add one, and then you add the new number you get to the original positive number per se. If
Yes.
the other one was positive, but if they were both negative, then I'd have to flip them both and then add
Yeah.
one to both, and then
You would have to
them
add one to
together.
both separately and then add
Yeah.
both together. Correct.
And then if you have a remainder in your final answer, you don't do anything.
Yeah,
Yeah.
like this one had an
Leave it.
extra carry of one, and
Carry.
that just gets
Yeah, you're
completed.
carrying.
Oh my god. Oh my god.
Get
Yeah.
carried.
Okay. Literally, I'm gonna get like executed. Okay. Got
So
it.
two's complement just means you add a number, you add a 1 to the end of the negative number then.
Yeah, the only difference between one's complement and two's complement is in one's complement, you flip any negative number. In two's complement, you flip and add one.
Yes. And don't add the carries in the final answer.
Right.
Oh my god, you're like such a god. Thanks.
It's just because I've done this before. This would be terrible if I had.
Oh yeah, that's so
I'm
true.
like sweating right now.
I'm trying to still piece together who's who.
I'm Charles.
What?
I sit in the very front.
I'm the kid that
I
writes
sit,
on the iPad.
Like, I was the one yesterday where he's like, oh, not yesterday, but it was Monday. He was like, where do you find 7 segment, or where do you find this thing? And I said 7 segment display, and he gave me a look like, no, I mean, where do you find these in everyday objects?
Well, you weren't wrong.
I didn't know like what he meant by it, because he's like, what is this? And I'm like, it's a 7 seg. I literally do circuitry as a hobby.
That's why I'm afraid to like answer any question because I'm like,
Yeah, no, because he doesn't word it correctly sometimes. So I literally just take what he says like as is, and I answer it, and he kind of like gets pissed at me because like I know a bit more than I should. Because he expects a basic answer, so he kind of looked at me like, "No, behind you, the clock," and I'm like, "Oh, well, yeah, no shit." You asked what it
I
was, and I
just sit
told
in
you what it was.
silence.
Yeah, I'm usually in like the middle front. Normally rows 2 or 3. I like to be at the front of the room.
I'm
Ideally.
always on the right side, but I always sit just by myself.
Yeah, I'm in the right side in the front. And like one time he took my iPad and like put it on the screen, and I was like, please don't let it lock. Please don't let it lock.
Oh my
Final
god.
answer-
Please don't be wrong.
So the
It's
final
got a
answer
dangerous
of
screensaver.
Oh
It's like
no.
It's like a fucking like anime screensaver. And I was like,
Oh
please,
my
like,
God.
please.
Gosh.
Telling on yourself.
Now I'm just gonna like make it like the Earth, like one of the generic backgrounds.
Yeah, just set it to the default like tablet screenshot or something, because
Yeah.
I would not
God.
trust that.
Smart.
It's so
He doxes
Okay,
your
so-
password live in front of the class.
So the final, hey, hold on real quick. The final for this one, the two's complement, 32 minus 19, it's still like 0.00001101, right?
Yes.
Yeah.
So we just like, so we added, so two's complement, we just add the 1 in the beginning.
Yeah.
And then like we don't add the 1 at the
Kinda.
end. One's complement.
Well, I mean,
Be careful what you think about that.
Yeah.
Because
Yeah.
you're always adding ones in two's complement. You're not always adding ones in one's complement. The only
Okay.
reason you'd be adding a 1 in one's complement is at the very end. If you have a
The
carry
carry.
1, then
yeah.
you add 1 to the end. If there's no carry, then whatever you got is your final answer.
Okay.
yes. So yeah,
In two's complement, you flip and then add 1 immediately, and then add those two numbers together.
and then you don't add the carry.
Right, the carry gets left out.
Perfect. Okay, I fully get those then.
Let's go.
These kind of take a minute to do. Well,
Yeah.
I guess it's kind of helpful if you do like know the numbers by heart, like in.
Absolutely.
Mhm.
But yeah, I don't know that, so I'm just gonna be dividing my little self. Okay, what else is like?
Why do some
Alright.
people hate on the? Hey, well, I never understood this. Why are so many people like anti-Montagne?
Because of his
Probably
tests.
just like yeah.
Anti what?
Like a lot, Montagne, the guy. Like a lot of people give him
Oh.
bad reviews.
Like
really bad
it's
reviews.
because he's very disorganized in his lectures, and he jumps from topic
Yeah.
to topic. Like that's really the only thing, and he's also super strict on his responses.
That's
So
it.
Is he the
Yeah,
only one
that's
that
what I've
teaches this
seen.
class?
Yes,
No,
he
he's
is.
just the only one that teaches it for this.
Yeah, there's
term. If we
others.
had waited till next
Yeah.
term, it would have been somebody else.
screw that. I want to get this done.
Yeah, me too. I want to graduate
Yeah.
in a year.
Let's
It's
go.
really not too bad once you just study. I think for me, I'm fine with everything. I just need to work on conversions. But like you said, if you just convert it to binary, obviously excluding the hex or whatever you said,
Yeah.
I have it written down. Then you can just easily convert it.
Mm-hmm.
If you can
Uh,
convert it to binary, you can get it to.
Mm-hmm.
So number
Okay.
5 on his little study thing, what does he mean by like designing an adder capable of adding 2 binary whose numbers of digits is 4 for each number? I don't know if he just worded it weird, but
He probably did. Let
confusing.
me look at the email.
God.
Uh,
Design, decode, multiply, demultiply. Okay, that's not bad. Truth table.
That's just the and then that's easy. That's just
Oh,
the
okay. Is
zero
that
zero.
the
Do
Like,
you guys
beginning
still want to
thing?
do it for the recording's sake?
oh,
Or
I mean, sure we could. I
Yeah,
mean,
why not?
Can we do 5 first though?
yeah, no, definitely
yeah,
do whatever's more confusing first.
Definitely 5.
yeah, because I don't even know what he's asking. Like, to
Literally turning into his lecture because he doesn't record.
Yeah, if only he did record, it'd be so much easier.
I want to record, but there's just it's really hard to in that room. Like,
I'm about
there's
to
so
bring a
many people.
camcorder.
Yeah, I don't know. If my
Wait,
laptop had a front viewing camera, I would totally use it, but it doesn't.
I'll just.
So I'd only be able to get audio.
I just want to bring a tripod and a camcorder and just set it like. I guess not even a camcorder.
Bring in
God,
like
so ancient.
professional recording equipment.
Like my Nintendo's.
So would
No,
you
no,
be
no.
cool with
Oh
that
my
though?
god.
Like a full ass like HD camera.
We get the
Well,
communications majors.
Oh no.
Or I guess film majors. What am I talking about?
Buy a couple $1,000 camera to record, and you're just sitting in your seat with it.
and the good news is we're halfway there, so
Have to go meet up with the TA. Are we good for tomorrow, or is this? A couple of us are gonna meet tomorrow at 3:00 p.m. So I'm pretty sure we're good for tomorrow.
it's gonna be on Zoom again.
I would hope
Yeah.
so. The guy that was wanting to do the 3:00 like review, because I'm basically just recording. The guy wanting to do the 3:00 one already left, so we can
Okay.
probably just talk in the study guide channel again to try to set something up.
Okay.
Yeah.
I'm gonna
So-
be honest. I don't really know what he means by number 5. Design an adder capable of adding 2 binary numbers whose number of digits is 4 for each number. I know how
So
to
I'm saying
design an
may-
adder capable of adding 2 binary numbers. That's just
So
like
is
a
he saying like
basic adder.
like 1,000? Like it has to be like 1,000 whatever and another 1,000 something. Like I don't even know.
Oh, I
He's
think I just figured out what he meant. Hold on. Give me a second.
Good
Find my notes
job.
on this. Hold on. You worded that really weird.
yeah.
I think what he meant was design an adder capable of adding 4 numbers. Because every adder takes in, like what we were doing, every adder
It's
was taking in 2
two.
bits.
Yeah.
And then it
Oh,
carries
We just
it and
I
did
then
think. Oh,
4
carries it.
I think
adders.
I know what he means. Yeah.
And then he did
like,
4 adders, so you just keep connecting more and more adders
So
to
it's
each
like
other.
with two.
Yeah.
Would that be just 2 adders connecting or 4?
It would be 4. You do
It'd
one
be
for every
4.
digit.
Mm-hmm.
Oh, okay, okay.
So I think that's what he meant. So let's see if I can draw
And then he
this
said
according
8
to
as well.
what's
Like that's
there.
that's a lot of paper space. Oh no, that was for Demux.
No.
Never
Yeah,
mind.
I was like, I don't think that's the same one that you
I was gonna
did
say, I'm like, that's a
stream.
lot of adders.
Yeah, I mean, I know we did one in class. There was like 3 adders together, and it wasn't that bad. So
Yeah,
So
but
let's
Yeah,
start
eight's
with
insane.
Yeah, let me just look at what you're doing over here.
actually let me give myself more space real quick.
I know. I always underestimate.
so now I know for future classes avoid one tag me.
make it very pointy.
Yeah, it's
I kinda
just
like
you might
it.
as well just so you don't worry about
I
getting
would do that just so you
because
don't
he
get
thinks it's
doxxed.
an AND gate.
Alright, yeah, makes sense.
And then we're also saying if you really, really want to be safe, you can actually just put XOR.
Yeah, XOR.
Oh yeah.
Like label them with words.
It should also be an XOR.
Yeah, I was like, you're missing that.
Let's do it this way. There we go.
Design an adder capable of 2 binary that adds 2 binary whose number of digits is 4 for each number.
Yeah, that's what we're doing right now.
You gotta do it at the gate level.
Yep, that's this.
Oh yeah, we're putting the
Yeah. Remember, you got to make the XORs very, very pointy, just in case. Just in case.
Yeah. I mean, I don't think for XOR he would confuse it because
Yeah, because it has the little gap, the line and stuff.
yeah, usually
I
the
think it's
line
more
will
for just
differentiate.
or.
It's more for or and yeah.
C output. Oh yeah, you have to label these. Oh my god.
Yeah,
Yeah.
see out.
CN. And then CN's yeah at the top.
It's not terrible.
And remember, yeah, and then if the S and it's like SO, S1 at the end, like when you keep adding.
Oh, okay, I remember doing this.
Yeah, I have it in my notes. I can't really screenshot
Yeah,
my
so then
notes.
basically if we're gonna do this 4 times, this C out is going to become the next C in
Mhm.
Yeah.
for the next one, and we're basically just gonna duplicate this entire thing.
Oh, this is easy. I know how to do this. It's just, so basically from X0, Y0 all the way to X1, Y3. You gotta draw
So
that
he's
4
basically
times.
just wanting us to do this 4 times.
Yeah,
Oh, that's
copy paste,
easy.
copy paste, copy paste.
But I hope he doesn't give us like actual numbers to input. Like I mean, it's not horrible, but
Oh wait.
yeah, I'm pretty sure
Is
that's
he
what he's
gonna do like
do.
an actual review day? Did he say he's gonna do that or
On
no?
Monday.
Yeah.
Oh, okay,
But
cool.
it's gonna be more. Apparently, people have been saying that you have to bring your own questions
Yeah,
and stuff.
yeah, that's how he
Yeah.
is. He didn't expect us to come with questions, so definitely I would ask him like this crap to see like how he does it, because that's probably how the test is gonna be structured.
Yeah.
Like if he adds numbers or if he just wants the architecture of them.
X0.
So it
Oh,
is
and then you
kind
just
of a pain in the ass.
copy and paste
Yeah,
it. Like,
basically what's gonna happen is you're gonna end up doing this over and over again. So if you wanted 4 numbers, you're gonna have this
It
top
do it,
thing
and you're just gonna do
duplicated
it
4
again,
times,
yeah.
and the C out of the first connects to the C in of the next.
okay, and then it would go. So it would double what you have right here, pretty much, if you needed
Exactly.
4.
If I wanted more space, I would just take this and duplicate it
Yeah.
exactly. So it would go
Okay.
0, 1, 2, 3, and S's would be S0, S1, S2.
That's
all the way.
one, and then Y0, Y. Okay, yeah.
Yeah.
Oh, so
I
that's all
think
that
that's what
question's
question
asking.
5 meant. He just worded that super weird.
Yeah, that's what I was like. What the heck is he saying?
Yeah, if anything, I'll just ask on Monday or Tuesday. I don't even know what's happening now.
Yeah, I know Monday's a review, but like.
I mean, we can
I
absolutely
can't believe
ask
he
him.
hasn't already confirmed though if it's in person or online. So.
Yeah, that's
Like,
a little
what
bit
if-
of
We
an
should
annoying
definitely ask him
thing.
about number 5 though,
Yeah.
Yeah.
because I want to know exactly if this is what he actually meant or if he meant something totally different. Because that is super weird wording.
Isn't it?
Yeah,
People adding
we're just gonna assume he meant that.
Yeah, I mean that's
We'll
all
have
we
to
can
remember
really
that
do
Monday.
for this section. Yeah. This and next.
So the out of the last one connects to the in of the next one.
Right.
Mm-hmm.
And if we were doing this at gate level, it would be the exact same thing. It was like we did earlier today, where we would have the
Yeah.
yeah. And then when we were drawing, like if we had to write numbers and label what the C ins and C outs were, the C in of the first one is always going to be a 0.
So
No matter
at the
what.
gate level, if
Isn't this the gate level?
This
Or
is the
the box
gate level.
Okay, yeah, and then the other one's the box level.
Mhm.
the box level would be like 4 boxes, right?
Dang, I ran out of space.
Yes.
I think so.
Fuck.
Yeah.
Yeah.
Yeah, because it's the same, like each chunk of those gates until the C out, all of those are literally one chunk. One chunk, one chunk.
Yeah.
So we have 2 there.
Got it.
Yeah.
Yeah. This whole thing is all
One box.
one full adder.
That is one adder.
This
Yeah.
one FA.
Yeah.
It's basically just copy pasting at that point.
I ran out of space. Unbelievable.
Yeah.
I'm writing so tiny. And he's gonna be like not legible retake. I'm like, oh.
Oh, yeah, I know you have to write it like why. Yeah, that's the order you have to write it in.
That's how I did it. I don't know.
I remember he
I
went
mean,
over
it'll
and he's
be
like,
going
if you
from right
write
to
it
left.
wrong, then
It was
it's all wrong.
S0, S1s, and then it was C in and outs. Or was it?
Oh, yeah.
hold on. How did he write it?
I have it written down.
No clue. I have an example written, but like, it doesn't really help me.
This was it, except for we just used numbers in the box exam. So where I have Y and X on the top of the full header, it was just like 1s and 0s and stuff.
Yeah.
Yeah,
So
because those are your inputs.
I have a screenshot. I don't know. Oh,
I
this is only
mean,
for one. I don't even know what I wrote because I wrote a full adder,
mhm.
just one of them, but I had 3 boxes. Wait.
one full adder is one box. If you have
Mm-hmm.
3 boxes, then that would be the box form, whatever you're doing. If
If
they're
you
all
have three
connected.
boxes, you're adding three different
3.
numbers. Yeah.
Okay.